Hello my dear future medicos, how are you all doing? I hope you all are doing well, and this is my third take because I was blabbering in the first one. Okay, so I welcome all of you to the second lecture of wave. Okay, in previous lecture we have seen different types of wave, and today's lecture is going to be one of the most important. Okay, because in this lecture we are going to talk about the wave equation, wave motion, velocity of wave, and so many topics that might confuse you. But have a piece of paper, write it down, all the confusion will vanish away. It is going to be very much easy, but have a paper and write it down. I am going to tell you 10 formula for velocity of wave and you are like, sir, there is only one wave going on, why should we have 10 different formulas? Because based on the situation, based on the given things, we have to change. Okay, it is just like that. If some patient, okay, or if you are going to, if you are a cook, let me assume that you are a cook or you are a chef. So based on the ingredients, whatever the ingredients is given, based on the ingredients you have to change your recipe, right? Based on the ingredients you have to change your recipe, right? So similarly, based on the formula which based on the data which they have given, we have to change our formula. So if they are asking the velocity of longitude transverse wave, let me say, if they are asking the velocity of transverse wave, there are 3 to 4 formulas. So which formula should I use, sir? What is given? Okay, if they are giving omega and k, use the formula which has omega and k. If they are giving tension and mass, use the formula which has tension and mass. So to avoid all the tension, have a piece of paper. Whatever I am telling you, just write down the formulas. Okay, whatever I am telling you, just write down the formulas. It will be super cool lecture. So previously we have seen waves, types of wave. What are the different types of wave? In that we saw longitudinal wave and transverse wave. Just to recollect all of them, I have included them in today's lecture as well. Okay, so today's lecture we are first going to discuss about different between wave. What are longitudinal wave, what are transverse wave, then displacement relationship and a progressive wave. This is the main topic of discussion. You should understand. Sir, will it be very much confusing? No, my dear students, it is going to be super easy. There is only one equation, okay, that can also be written in 4 to 5 different forms. Okay, then after that we are going to discuss what some basic definition which we have already seen, like time, amplitude, velocity, displacement, everything. Then speed of wave motion. Okay, first we are going to discuss transverse wave and longitudinal wave. In transverse wave, the particle, don't get confused between particle and wave. Particle is one single rod. Okay, this one single rod is my particle. The complete motion is wave. Okay, if I talk about velocity of particle, I mean the velocity of this. If I talk about wave, I mean this. Okay, so particle and wave are two different entities. Don't think that particle and wave are same. Motion of particle is perpendicular to motion of wave in transverse wave. So medium vibrate perpendicular. What is medium, sir? Particles are medium. Okay, so the mediums are perpendicular, or the disturbance is perpendicular to the propagation of wave. In longitudinal wave, the disturbance and this thing. Where is my another slinky? I could see only one. Ah, it is here. Okay, so this is a slinky. Can you see this? Right? If you could see this, then you can see that the particle is going in y-axis, wave is going in y-axis. Both are, what are both? They both are in the same direction, man. Okay, they both are along the same direction. Okay, they are characterized by crust and trough. If I have a wave, then I will be having crust and trough. The top thing is called crust, bottom is called trough. Whereas in a longitudinal wave, I am going to have compression, they are compressed, then rarefaction, they are little bit away, then again we will have compression, then again rarefaction. Okay, so what is a wavelength? Wavelength is wave of length of one complete wave. So here what is a wavelength? Distance of crest plus trough, or what we can say, the distance between two consecutive points having the same plane, or distance between two consecutive crust. I can even write this as the distance between two consecutive crust. Okay, this is wavelength. Okay, so the distance between two successive crust or trough. If you are taking top point, take top point. If you are taking bottom point, then take this two bottom point and find the distance. Or else you can take distance of one crust plus one trough. Similarly here, the distance between compression to another compression, or rarefaction to rarefaction, or you can simply say distance of compression plus distance of rarefaction. Any way you can define it. A crust and trough make a complete wave. So as I said previously, what is wavelength? Distance of one crust plus one trough, because one crust and trough will make a complete wave. Here, one compression and one rarefaction will make a complete wave. Any difficulty? Transverse wave is possible only in solid and surface of water. In previous example, we might have seen that if I am sailing a boat on the surface of water, what type of wave will it produce? Or else if I am hitting, okay, not in previous lecture, in this lecture that example is there, but because I have already recorded for JEE, I thought that it was previous lecture, okay. But in previous lecture, we have seen what will happen if I make some disturbance on the surface of water. If I am hitting the surface of water, water is going to go in this direction also, and as my disturbance is in this direction, it will going to have a ripple. So like transverse wave. So disturbance is in this direction, particle are moving in this direction. So transverse wave is possible, but where is it possible? Only on the surface of liquid. Inside the liquid, you can't go and hit the water like this. Inside the liquid, no, nothing will happen. Inside the liquid, only this can be done. Longitudinal wave can be produced in solid, liquid or gas. Sir, how in gas, sir? Have a chamber full of gas. Take a piston. Hit the piston up and down, up and down, up and down. It is going to push the gas. Okay, push the gas. So gas is going to compress rarefact, compress rarefact, compress rarefact. Okay. Medium must possess the property of rigidity. It should have a property of rigidity. It should be rigid. So for example, neta or Young's modulus. Okay. Why, sir? Because in order to find the velocity, we need these terms. Longitudinal wave should have a property of volume velocity, basically bulk modulus. Sir, why do we need bulk modulus? For liquid and gas, we find only bulk modulus mainly. Okay. So whenever we need to find the velocity of wave which is in liquid or gas, then we need bulk modulus. Okay. Everything will come to a conclusion when we are finishing this lecture. Don't worry. Okay. Just keep on noting. These are all the basic things. This PPT will be provided to you, so need not worry about that. But at the formulas which I are telling, please write it down. If you are writing it down, it will be clear. This is the formula for this, this is the formula for this, this is the formula for this. If you are not writing it down, it may lead to some confusion. Pressure and density doesn't vary. Okay. When transverse wave is going, then pressure and density will not vary. But in longitudinal wave, pressure and density will vary. How, sir? See, if I am pushing the spring, okay, if I am pushing some air particle, let me assume I have some gas and I am pushing the gas. What will happen? The gas will compress, then density will be more, then it will go away, density will be less. Are you able to follow? So pressure may vary, okay, during propagation of wave. What is mechanical wave and non-mechanical wave? Basically, sound wave is an example of mechanical wave, and mechanical wave requires a medium for propagation. In non-mechanical wave, we don't require a medium for propagation. Produced due to continuous vibration. This is produced due to continuous vibration. Okay. If at all I need to have a mechanical wave, I need to give continuous vibration. I need to keep on vibrating the particle. If I stop, the wave is going to stop. Okay. So basically the source is continuous vibration. It can be in this direction or in this direction. Okay. But non-mechanical wave are produced by accelerated charges. It is produced by accelerated charges. So accelerating charge particle produce non-mechanical wave. About this we will be understanding in depth in electromagnetic wave. So EM wave are produced by accelerating charge particle. This can travel only through medium. If there is a medium, they can travel. If there is no medium, they can't. Yes. If there is a medium, they can travel. If there is no medium, they can't travel. So sound cannot travel in vacuum. Therefore, if you are going and shouting on moon, no one will hear you because there is no medium. Okay, I don't know the thing which I did was recorded or not, because maybe this mic might have cancelled my noise. Okay, so already morning I recorded 2 lectures, but due to noise I have to re-record it. So what I was telling is, if you are going and shouting in moon, people may not hear you. Okay, if the audio is already audible, then no problem at all. If it is not, then I am repeating it, because there is no medium in moon. If there is no medium, then sound cannot travel from me to you. Okay, if I am telling hello, then what is happening? I am producing a vibration. This vibration is getting compressed air fraction with some air molecules, and it is receiving you. If there is nothing in between, if there is no matter or no medium, then I will be producing some vibration, but vibration cannot travel over there. Are you able to follow? Let me assume I need to hit you. Okay, I need to hit you. So I am just tying a rope around you, and I am just going to splash the rope over here. This is going to come and hit you, right? So let me assume this is you. Okay, this is you, this end is you. If I want to transfer some energy, see, I am giving some energy, it is going up to there, right? Now let me try to do that again. This is you, I want to hit you, I am doing. Sir, you are doing some vibration, but there is no medium to take the vibration from one place to another. So mechanical wave requires what? Medium for transport. Whereas non-mechanical wave can even travel through vacuum. For example, sunlight from sun can travel to earth, right? Without any medium. Mechanical wave can be longitudinal and transverse. Mechanical wave can be both longitudinal wave and transverse wave. But non-mechanical wave is transverse only. So the example is light wave. Light wave is transverse in nature. Okay. Particle of the medium oscillate. In mechanical wave, particle is oscillating and taking the energy from one place to another. Here, electric field and magnetic field will be oscillating. Okay. Vibration of particle are responsible for transport of energy. Who is responsible for transporting my energy and momentum? Particle, because I am giving vibration to one particle, that is giving to another particle, that is giving vibration to another, and my energy and momentum is transferred. Here, energy and momentum are transferred in terms of electric and magnetic field. Okay. Velocity is more in denser medium. It means that when sound is traveling in solid, it has more velocity than velocity in liquid. And if I am traveling in gas, the velocity is reduced so much. Okay. So for example, the velocity of sound in air is nearly 342 meter per second. So if I am talking, then you will be able to hear the sound with the speed of what? 342 meter per second. Okay, my sound can travel with the speed of 342 meter per second. But let me assume that I have a medium. I have iron nearby. Okay, iron nearby. And another end of iron is in your ear. If I am striking the iron, the sound, because now it is not traveling in air, this sound is going to travel in medium. What is that medium? Sir, air is also medium. Yes, so that is gaseous medium. But as we have some iron, it is solid. So speed of sound in solid is 1500 meter per second. If you, I am not telling in a wrong way, this is just an experiment, nothing else. If you go and keep your ears on a railway track, sir, why should I? It's just a science experiment. Okay, I am not giving any plan for any other things. Okay, because students' condition are worsened these days. Okay, they may take things out of context and tell that sir only said to go and sleep on railway track. So if you are keeping your ears on railway track, and if a train is coming from far distance, you can hear the sound of train in railway track faster. Sir, how, sir? Because the sound is traveling in what? Solid medium. Then the sound which you normally hear in air. So if train is coming, before you can hear the sound of train normally in air, if you are going and keeping your ears on the railway track, you may hear it very well. Because the sound travels faster in what? Solid. Okay. Sir, what about vacuum? In vacuum, the velocity is zero. It will not travel. But for our non-mechanical wave, for example, light, velocity is maximum in vacuum. Then velocity is less in gas. Then in liquid. and in finally the velocity is least in solids. Okay, so you might have studied that a light travels slowest in what? Light travels slowest in diamond. If you are having a diamond, speed of light decreases, right? Because it is solid. Okay. Given below are some example of wave. We have to tell whether it is transverse wave, longitudinal wave, or combination of both. Motion of a kink of a longitudinal spring. If I have a spring and if I produce a kink in it, this is what a kink is. Then what type of wave is formed? It is transverse wave, longitudinal wave, or both. So if you are giving a kink, then see the direction of propagation of particle and direction of propagation of wave are perpendicular. So it is transverse wave. Okay, it is wave, not wave, man. Wave produced in a cylinder contained by liquid by moving a piston. Let me assume that I have a cylinder containing liquid, and if I am pushing the liquid, what will happen? Compression, rarefaction. Compression, the motion of the particle and the direction of motion is same direction, so it is longitudinal wave. Wave produced by motorboat sailing in water. If there is a motorboat which is sailing in water the motorboat is running, then what type of wave is produced? Sir, motorboat is going front, right? Motorboat is going front. Then wave is water will also go in front, so it will be a longitudinal wave. But if you observe, when it is going right, the motorboat is having some pressure on the water, so it is pressing the water as well. So if you are going in motorboat, have you seen this motorboat will be having some jerk like this due to waves and all. So there will be some ripple formation also. There will be some ripple formation also. So if motorboat is going, it is going to push the water in front direction also. Apart from that, when motorboat is going, surrounding to the motorboat, some waves are produced. If you see the direction of wave is going in this direction. Motorboat might have gone in this direction. So assume that this is motorboat, this is going forward. So this motorboat will take some water along with it. So direction of motion of particle and wave is in the same direction. But when it is going in this direction, it is producing some wave in this direction also. The ripple, the particle are going like this. So the direction of water is this, but wave is propagating in this direction. So it will produce longitudinal wave and transverse wave also. Okay, so both wave are going to be produced. Both the waves are going to be produced. Okay. Finally, so okay, if instead of this, if the question is wave produced by submarine sailing in water, if there is a submarine which is sailing in water, sir, where do submarine flow, where do submarine ride? What to tell? Where, I don't know how to tell that. Just a minute. Okay, I should change the name also hereafter. Okay, no problem. So I got a message that I should change my name in PPT slide. So it was first A2K. Now they said me to write full name. Now they are asking me to mention it as Abhi sir. Okay, sir. So if at all I am talking about submarine, where do submarine go? Submarine floats at the, not floats, submarine travels on the surface of water or inside the water. If it is traveling inside the water, then only longitudinal wave is produced. Transverse wave is possible only at the surface of liquid. Okay, so as the motorboat is traveling on the surface of the water, we are going to have what? Transverse wave. Okay. Ultrasonic is an example of sound wave. So sound wave is an example of what? Transverse or longitudinal? Longitudinal. Now we talk about the displacement relationship in a progressive wave. If there is a wave, okay, this wave is moving in y-axis. The particle of the waves are moving in y-axis. The particle of the waves are moving in y-axis. This is y-axis. The particle are moving in y-axis. Okay. Particle are moving in y-axis. Where is the wave moving? Wave is moving in x-axis. So if I ask you, can you write the equation of this simple motion? Yes sir, you will tell this is simple harmonic motion, so I can write it as y is equal to a sine of omega t, because with the time the displacement of this particle is changing, right? Displacement of this particle is changing. If I ask you to write for this, you will tell I can again use the same equation. Again for each particle you can use the same equation because each particle is having a simple harmonic motion. But when we consider this to be a wave, and if I am asking you the displacement, tell me the displacement pa, what will you tell? Sir, each particle are at different height. So if you want to ask me the displacement, you should tell of which particle, because each particle is at different height. So if you want me to find the displacement, you should tell you want the displacement of fourth one, fifth one, sixth one, or which one. Okay, so I am telling that I want to find a fifth one. Sir, if you are telling you want to find a fifth one, you should mention that in equation also. Yes sir. So this equation for wave, y is equal to a sine omega t, is for one particle, but now we have n number of particles. N number of particles is called what? Wave. So in order to write the equation of wave, we use a sine of omega t minus kx. This x is representing the position, and I will be explaining what is k and what is omega. Don't worry about that. Okay, so this is the equation of wave. So what is the displacement of a particular particle at a particular time? Because with time the displacement vary. If I am talking about this particle, so I have fixed the particle, and with respect to time, because if I see at this time this is down, if I see later it is up, now down, if I see now it is up. So the displacement is going to vary with respect to time and with respect to position. All the particles are not having the same position and same time, right? Where A is what? In this equation, A is called the amplitude. Amplitude means maximum displacement. Okay, these are the terms we have already seen. So this is my amplitude. Okay. What is time period? Time taken for one complete oscillation. What is frequency? These are all the terms which we have already seen. Frequency is, see, frequency is nothing but number of oscillation completed in 1 second. Right, number of oscillation completed in 1 second. So formula can be given as frequency is equal to, or mu is equal to 1 by time period. So number of oscillation completed in 1 second is called frequency. Then phase. So phase is nothing but the position and direction of motion. So in which position? Okay, like I said, k into x is representing what? The position. About which particle are we talking? Okay, and in which direction the wave is going? Everything is determined from where? The terms which are inside the bracket. So for example, kx minus omega t plus phi. This phi is called the initial phase. Okay, so this whole term is called phase, because this represents, okay, just like our face represents ourselves. Okay, just like our face represents ourselves, this phase is going to represent which particle are we talking about, what is the position, what is the direction of the wave. Okay, even as a matter of fact, using this formula we can find the velocity of wave. Okay, what is wavelength? Distance moved by a one wave. Okay, what is the distance moved by one wave? So simply we can call that as, if this is one complete wave, then what is this distance? Or we can tell that distance between two consecutive crust, or distance between two consecutive trough, or we can even say that distance between 2 points which are in same phase. Velocity. Simply, what is velocity? Sir, distance traveled. If I take this to be my wave, then what is the distance traveled? So distance traveled is equal to lambda. How much time will it take? The time taken for one oscillation is equal to time period t. So I can very well write that velocity is equal to wavelength divided by time, or else I can rewrite this as 1 by time period is equal to frequency. Okay, or else I can rewrite this as omega by k. Sir, how do we get this? I will let you know, because I haven't defined omega and k till now. So relationship between frequency, velocity. So I have already given velocity is equal to omega by k. Remember this formula, okay? Or else wavelength by time or wavelength into frequency. So what is this k? K is called wave number. Formula is equal to 2 pi divided by lambda. 2 pi by lambda. And in frequency part, let me introduce you to a new concept. Okay. In frequency, let me introduce to a new concept called angular frequency, which is omega. This angular frequency is equal to 2 pi divided by t, or else 2 pi nu or 2 pi f. So nu and f are frequency. They are just different representation. Okay. For example, you can call me as A2K sir or Abhi sir. Okay. So V is equal to omega divided by K. So how do we arrive at this? They both are same, sir. Sir, what are you telling? This and this is same. Yes. If I substitute omega is equal to 2 pi divided by t. If I substitute k is equal to 2 pi divided by lambda. If I cancel them out, what I am getting? Wavelength by time. Wavelength by time. Okay. State rank list vandiruchu. Okay, I think I have to go live. As soon as I finish my recording, I have to go live because in Tamil Nadu, we have got state rank list. Okay. So based on rank list, I have to predict what college they may get. If this is my wave, a wave theory is given by, so this is my wave. So just remember, this is my A, sine of whatever is in front of x is called k, and whatever is in front of t is called omega. Okay. Now, actually it is 80, not 80.8. Let me recorrect it. Okay, they are asking me amplitude. What is amplitude? This A is amplitude. So amplitude is going to be 0.005 meter, or in millimeter I can write this as 5 millimeter. What is my wavelength, sir? From this formula I know my k is equal to, because here we have mentioned 80.0 only. Okay, so k is equal to 80. So k can be written as 2 pi divided by lambda. So what will be my lambda? Divided by 80. So if you are solving this, 2 pi divided by 80, I will be getting 0.0785. Next, they are asking me to find the period and frequency, time period and frequency. If this is my omega, this is my omega. How do you know, sir? It is in front of t, so omega. Omega is equal to 2 pi divided by t, and omega value is 3. So time period is equal to 2 pi divided by 3. 2 pi divided by 3. So my time period is equal to 2.09. Frequency can be written as 1 by time period. So 1 divided by 2.09 is equal to 0.478 hertz. Time period is in seconds and wavelength is in meter. Okay, wavelength is in meter. Any difficulty? So such question you should practice. Okay, va? So displacement relationship, how can I write waves in different form? Let me show you. Okay, wave can be written as A sine of kx minus omega t. So okay, kx minus omega t. I can write k as 2 pi by lambda. Okay, am I getting phone call? No. X minus 2 pi by t into t. Any difficulty? I can take this 2 pi common. I can take this 2 pi as common. So I can write wave, same wave equation can be written as, any difficulty? And what will happen if I take lambda outside? Okay, so just remember this formula. All others are different way of representing it. Okay, if you know this formula, you are good to go. If I take, okay, lambda outside, so this can be also written. Or let me say I am taking k outside. From this equation, if I am taking k outside, if you are taking lambda outside or if you are taking k outside from this equation, both are one are the same. Because if you are taking lambda outside, you will get 2 pi by lambda. 2 pi by lambda is nothing but k. So if I am taking k outside, I will get a sine k into x minus omega by k into t. Because if I have to take k from this term, I have to multiply and divide both by k. So k by k, that k is taken out, denominator k. What is omega by k? It is velocity. So a sine kx minus vt. This is also equation of wave. And if instead of k I am taking omega outside, what will I get? If instead of k I am taking omega outside, I will get omega k by omega x minus t. So what is omega by k? Omega by k is velocity. So a sine x by v minus t. X by v minus t. Any difficulty? Any difficulty? I don't think you should have any difficulty in this. Okay? Yes, sir. So these are all different methods of writing wave equation. Okay? But the most common and general method is this one. Just remember this. Everything is derived from this only. Sir, if they are giving like this, what to do? Just multiply omega inside. Sir, if they are giving like this, multiply by 2 pi inside, you will get the same notation. How to find the direction of propagation of wave? Whether the wave is going in positive direction or negative direction. How can I know? Very simple. If the wave is written as or in both the terms, one term is positive, another term is negative. If one is positive, another is negative. Okay, if one term is positive, in this kx and omega t, one term is positive, another term is negative, then wave travels in positive axis. Wave is traveling in positive axis. Sir, how to know in which axis it is traveling? This x is representing that. What is that x representing? In which direction the wave is going? So, positive or negative is determined using this symbol, whether it is positive or negative. Okay. And direction, whether it is x axis, y axis or z axis, is determined from this variable. If I write wave like this, kx plus omega t minus kx minus omega t. If I write equation like this, if both are positive or both are negative, if both the terms are positive or both the terms are negative, then wave travels in negative axis. If both the terms are positive or both the terms are negative, then wave is going to travel in what? Negative axis. So simply remember, if one is positive, another is negative, then positive. If both are positive or both are negative, means negative. Any difficulty in this? Okay. Okay, sir. Now how to find the speed? So I have already said you how to find a speed, but I will just derive you in few lines. Wave is given as a sine of kx minus omega t. And this particular term is going to determine my direction. So if I take this term alone, because this term determines direction of wave, right? And what is this term? It is displacement of particle. It is not of wave. It is displacement of particle. Okay. So if I take this term alone and if I am differentiating with respect to time, if I differentiate the whole equation with respect to time, what will I get? K dx by dt minus omega dt by dt, right? If I differentiate time with respect to time is equal to 0. This will cancel out. So what is dx by dt? X is representing the position of the wave. So if I am differentiating that with time, it will give me velocity of what? Wave. So k into velocity of wave is equal to omega. So velocity of wave is equal to omega by k. This is how we got that formula. Or I have simply said you velocity is equal to distance by time. What is the distance traveled by the wave? Lambda. What is the time taken? T. So lambda divided by t. Okay. If you are multiplying lambda by t by 2 pi and dividing it by 2 pi, this 2 pi by lambda can be written as what? K, and 2 pi by d can be written as omega. Simple. Okay. So this is velocity of wave, and wave travels with constant velocity. Okay, sir. And if you see the velocity is positive, it means that what? The wave is traveling in positive direction. So if one term is positive, another term is negative, it means that wave is traveling in positive direction. Sir, what will happen if I take both the terms to be positive? If I am taking kx plus omega t, then as per my simple notation, what I have said, if both are positive, wave is traveling in negative direction. So if you are differentiating this, you are going to get k into, right, x is wave displacement. So if you are differentiating, you will getting velocity of wave plus omega is equal to 0. So velocity of wave is equal to minus omega by k. What does the minus imply? It is coming in opposite direction. Wave is moving in opposite direction, so negative direction. So if both are positive, wave is moving in negative direction. Remember this. So we have already spoken about speed of wave, right? If I want to find the speed of particle, what is the speed of particle? Okay, this is not speed of wave, it is speed of particle. So y is equal to a sine kx minus omega t. If I differentiate y, what is y, sir? Y is representing the displacement of particle. If I differentiate that with respect to time, I will getting velocity of particle. Don't confuse yourself with respect to velocity of particle and velocity of wave. Both are entirely different things. Particle is the velocity with which a particle is oscillating. Velocity of wave is representing the velocity with which the wave is propagating. If I differentiate, I will be getting a sine. Okay. If I differentiate, just a minute, let me rewrite it as omega t minus kx, just to avoid few simple confusion. Okay, if I differentiate sine omega t, I will be getting cos omega t, right? Cos omega t minus kx. And if I differentiate this omega t, I will be getting omega. This is my velocity of particle. If someone asks me what is the maximum velocity, maximum. So maximum means this term should become 1. And if that term become 1, what will I get? Maximum velocity of the particle is this. Sir, while discussing about the velocity of wave, we never discuss about maximum, because this velocity is constant. At any moment, if you are checking the velocity of wave, this is going to be constant. But the velocity of particle is not going to be constant. How, sir? Because if you see, the particle is going up, then down, up, down, up, down. So while the particle is going up, the velocity reduces. At the top point, the velocity is 0. Then the direction changes. It is coming down. Velocity increases. After a certain time, velocity decreases. Then it becomes 0. Again, it is coming up. So this velocity changes with respect to time. If at all you need to find the maximum velocity, it is going to be omega times a. Okay. Now let us talk about velocity of the wave. This is velocity of particle. Don't confuse yourself. This is velocity of particle. Now if they are asking me to find the velocity of wave, sir, velocity of wave can be written as omega by k. Yes, sir. But if they are giving me rigidity modulus and pressure, or rigidity modulus and density, then how can I find, sir? So velocity of transverse wave can be given by neta by rho. So velocity of transverse wave is given by neta divided by rho. Just remember all the formula. Velocity of transverse wave. Okay. If they are giving neta and rho, whereas neta is rigidity and rho is density. So in most of the formula, you are going to have denominator as rho. Okay, numerator will change. And remember that in solid, speed of transverse wave and longitudinal wave are not same, they are different. Okay, so one formula for transverse wave, I am writing this formula. When I am going for extended solid and I am writing the longitudinal wave velocity, I will be writing different formula. So remember, for transverse wave and longitudinal wave, we have different formula. Sir, what about liquid and gas? If I am talking about liquid and gas, then there is only longitudinal wave. There is no transverse wave. Okay. So in solid alone, transverse wave is possible. In liquid and gas, longitudinal wave is only possible. Okay. So remember the formula, velocity is equal to root of neta divided by rho. So let me come to this formula later. Speed of longitudinal wave. Okay, we saw speed of transverse wave. Now we are seeing what? Speed of longitudinal wave. Previously we saw neta by rho, but here we have b plus 4 by 3 times neta, where b is called bulk modulus. And this formula is valid for extended solid. Okay. So in this you need not remember everything, just remember the formula. And neta is rigidity modulus. What is rho? Rho is density. In case the solid, okay, if the solid is long rod or bar, if the solid is, let me say a 3-dimensional object, okay, basically it has some area, then we find rigidity modulus. If we are considering it to be very thin, if at only length, so instead of neta, we are going to represent it by y, Young's modulus. So nothing has changed. Instead of rigidity modulus, if the rod is long, then we are going to find Young's modulus. So y is Young's modulus. There is nothing change. Okay. Okay. So these are all longitudinal wave. In transverse wave, we have rigidity modulus. In this one, longitudinal wave, we have this one. Rho is density. Okay. The speed of longitudinal wave in liquid, if there is liquid, if it is solid, then y. If it is liquid, then b. B is bulk modulus. Okay. Again, in gas, bulk modulus. So all the formula, let me put in summary right now. Okay. Instead of putting in summary later, let me write all the formula in summary right now. Okay. What are the speed? If I am talking about the speed of transverse wave and longitudinal wave. So if I talk about transverse wave, the velocity can be written as neta divided by rho, whereas neta is rigidity modulus. Okay, rigidity modulus. Also, the velocity of transverse wave can be given by tension divided by mu. Mu is mass per unit length, or I can write this as m into L. This is the formula which I didn't teach you. Okay. I said we will teach later. Okay, so avoid confusion, I have left this formula alone. Now if I talk about extended solid, the velocity in extended solid for longitudinal wave is beta plus 4 by 3 times neta divided by rho. If we are simply talking about solid, velocity is equal to Young's modulus. If it is rod, Young's modulus by rho. Okay, for gas and liquid, it is bulk modulus by rho. Any difficulty? And also there are few formula which I will be teaching you. So the speed of transverse wave in a string, if it is a solid, okay, if it has some certain area. So okay, if it has some area, we can find rigidity modulus. If it has only length, we cannot find the rigidity modulus. So in order to find that velocity, we are going to use tension divided by mu. T is called the tension and mu is mass per length, mass per unit length. So this formula can be written as tension divided by mass per length. Sir, how do I know whether I have to use this formula or this formula? Whatever is given in the question, whatever is given, if they are giving you neta and rho, use this formula. If they are giving tension and mu, use this formula. Okay. So apart from this, all the formula just write velocity of longitudinal wave in solid, liquid, gas, nothing more. So Newton also came up with the formula where he said velocity is equal to B divided by rho. And this B can be replaced by pressure also. Okay. So in all the formula we are going to have density in the denominator and modulus. So modulus has the dimension of what? Pressure. So pressure in the numerator. Okay. So if it is liquid, then beta. If it is solid, then neta, or y, Young's modulus y. Okay. So he took that B is isothermal. We are finding this at isothermal. It means the temperature is constant. So how he came from this formula to substituting B instead of P? So let me tell what is B. B is bulk modulus. Bulk modulus is nothing but change in pressure, that is pressure exerted divided by change in volume, delta V by V, or we can write this as D. We can write this as D. No issues. Okay. So if I am taking an ideal gas in isothermal condition means pressure is temperature is constant. Okay. So what is my ideal gas equation? PV is equal to nRT. You need not remember all the things, just the final things is required for the exam point of view. If I differentiate this with respect to volume, if I keep P like this and I differentiate volume, I will getting dV by V. Sorry, dV by dV if I differentiate. Plus if I keep volume like that and I differentiate pressure, I will getting. Are you able to follow? I am keeping P like this and I am differentiating V with respect to volume. Now I am keeping V like that and I am differentiating pressure with respect to volume. All of these are constant. So if I differentiate constant, I will be getting as 0. So my pressure is equal to, if I take this term there, I will be getting minus V dP by dV. And I can rewrite this as minus dP divided by dV by V. And what is this, sir? This is my bulk modulus. So bulk modulus can be replaced with what? Pressure. So my volume, sorry, my velocity, which was bulk modulus by pressure, can be written as, so I'm extremely sorry, it is not bulk modulus by pressure, it is bulk modulus by density. Can be written as pressure divided by density. Okay. But when they found experimentally, they found that the answer that we got for gas is not exactly matching the experimental part. So they made some Laplace correction. Okay. So initially velocity was root of pressure divided by density. But once they applied the Laplace correction, they came up with the formula and said for each gas we should apply gamma value. So what is this gamma? This gamma is equal to Cp by Cv, or you can write this as 1 plus 2 by F, where F is degree of freedom. For monoatomic gas 3, for diatomic 5, for triatomic it can be 5 or 6 based on linear or non-linear combination. Okay. So this is what is Laplace correction, and Laplace correction is not a part of NEET examination, so you need not worry about that, but just remember the formula. In case if they are asking, just put the value and you will get the answer. Okay, so Laplace correction is repeated. Now let us try to solve few questions. A wave is traveling in positive x direction. So see, this x is representing what? Direction of wave. This y is representing what? Direction of particle motion. So all are in x direction, but they are telling positive. So positive means one should be positive, negative, positive, negative, positive. Both are positive. This cannot be my answer. Maximum displacement is 1. So amplitude should be 1. Everyone has amplitude of 1. Okay, sir. Wavelength is equal to 2 pi. From wavelength I can find my k. So 2 pi divided by lambda is 2 pi. It is given in the question. So my k value is 1. So it should have y is equal to a sine kx minus omega t, right? Kx minus omega t. So if I substitute the value of k to be 1, I should get 1 sine 1x. Only in one option we have 1x. It has 2 pi, 10 pi. Okay. And how to find omega? Omega is equal to 2 pi f. 2 pi f is equal to 1 by pi. So answer is 2. So you should have 1 sine of x minus 2t. Which option is matching? This option. Are you able to follow how am I solving? It is very easy. Okay. Similarly, just try to solve this question. Okay, not at all difficult. They have given amplitude to be 2 centimeters. First term should be 2 centimeter. Everyone has that, sir. Okay, traveling in positive direction. If we are traveling in positive direction, one should be positive, another one should be negative. So both are positive, wrong, sir. Both are positive, wrong, sir. In x-axis, okay. Speed they have given. So from speed, if they have given omega, can I write this? Sorry, if they have given velocity, speed, velocity or speed, can I write this as omega by k? Omega by k. So the ratio of omega and k is given as 128. If I am dividing this with this and this with this, I will be getting 128 only. Okay. What they have given apart from that? 5 complete wave. There are 5 complete wave. 1, 2, 3, 4, 5. Okay. So this will happen if you are not planning your preparation. Okay. In the beginning, you will be taking lots and time. In the end, you don't have time. Okay. So it will happen like this. So plan accordingly. Okay. 1, 2, 3, 4, 5. So the length of 5 wavelength. One wave will have a wavelength of what? Lambda. So distance of one wave is lambda. There are totally 5 wave. So 5 lambda. 5 lambda fits in 4 meters. So in 4 meter, 5 lambda is fitting. So what is the value of lambda? 4 by 5. From the value of lambda, can I find k? Yes, sir. K is equal to 2 pi by lambda. So 2 pi divided by 4 into 5. 5 2s are 10. So I will be getting pi by 4 into 10. What is the value of pi? Sir, 3.14. Let me take 3.14 to be 3. What is 3 by 4? Sir, 0.75. 3 by 4 is 0.75. So 0.75 into 10 will give me 7.5. Which option is matching? This one or this one? Sir, this one. Okay. So once you know omega, sorry, when you know k value, you know v value. So omega can be written as v into k. We know velocity 128. We know k value which is 7.85. If you are multiplying both of them, you should get this answer. Okay, just try to find that out. The wave described, so wave is described using this equation. Okay, they are asking whether it is in positive direction or negative direction. Just see this, one is positive, another is negative, so it is moving in positive direction. So negative of direction, negative, wrong. Okay, they are asking me to find frequency and wavelength. If you see, wavelength is given as 0.2 in both the options. I mean both the options, B and C. Option D is eliminated, right? If you are preparing for NEET examination, NEET is going to have one correct answer. So out of the 4 options, one should be correct. And I know that A and D are wrong. Both these options are wrong, right? So either of them should be correct. And both of them are telling that lambda is 0.2. So don't find lambda at all. We just need to find frequency. So the term which is in front of t is called omega. So omega, which is basically 2 pi into f. And the value is given as 2 pi. Are you able to follow? Omega is equal to 2 pi and omega formula is 2 pi f. From this, I can find f is equal to 1. So I am getting frequency of 1 hertz. Then how to find a wavelength? This term is called k. So k is generally 2 pi by lambda and the value given here is 10 pi. So lambda is equal to, cancel this pi and pi, you will be getting 2 by 10, which is nothing but 0.2. Which of the following statement is true? Okay, which of the following statement is true? Both light and sound wave are transverse? No, sir. Sound wave are longitudinal wave. Yes, sound wave are longitudinal and light is transverse. This is the correct option. Velocity of a particle at time t. We have already described this, right? Velocity, let me read to this. Velocity, y is equal to, okay, y is equal to a sine of omega t minus kx. omega t minus kx. If I differentiate this with respect to time, what did I get? Velocity of particle is equal to omega a cos of omega t minus kx. Right. This is what I got when I differentiated with respect to time. So this is the velocity of particle. Okay. And they are asking if what is the velocity of particle at t time. So maximum, what is the velocity of maximum velocity possible? Maximum velocity is equal to omega times a. This is my maximum velocity. Relationship between velocity and slope. Okay. In order to get that, just write the equation. You can just remember the formula, that is not an issue at all. Omega t minus kx. If I differentiate this equation with respect to time, what will I get? Differentiate with respect to time. If I differentiate this equation with respect to time, I will be getting velocity of particle is equal to omega a cos of omega t minus kx. And if I am differentiating the same equation with respect to x, what will I get if I differentiate this whole equation with respect to x? dy by dx is equal to dy by dx is equal to a cos of omega t minus kx, and if I differentiate the term which is inside, I will be getting a minus k. Okay, minus k. So what is basically this term? This is dy by dt and this is dy by dx. Okay, if you are dividing both of them, what you will be getting? Dy by dt divided by dy by dx. Dy by dx is slope of the graph when it is plotted between y and x. Okay, so this is my wave. Divide both of them. Cos term will get cancelled. You will be getting omega a by minus ka. Cancel this out. What is omega by k? Velocity. What velocity, sir? Velocity of wave. And what is this term? Velocity of particle equal to minus velocity of wave into dy by dx. I have already mentioned that velocity of wave is always positive, right? That negative is going to determine it is going in front direction or back direction. Okay. So they are asking you about the velocity of particle. What is the direction of velocity of particle? Whether the particle is going up or down, that is what they are asking. How to find, sir? You just need to find the slope. If they are asking what is the velocity of particle at this point, find the slope. Whether the slope is positive or negative, sir, positive, sir. What will be the slope at the top point? 0, sir. Here negative, sir. Here 0. Here positive. So slope can be simply written as the value is increasing, slope is positive. At maximum, slope 0. Value decreasing, slope is negative. Okay. So at this point, velocity is positive. Velocity is always positive. Slope is positive. So positive into negative. So particle will have negative velocity. It means what? Particle is coming downward. So let me try to show you with this apparatus. Okay. I think this is the case. Okay. This is our wave. And I am asking you to find the velocity of particle at this point. Now see what is going to happen. Whether the particle is going to come up or down. Okay. I am going to rotate it. See what happened to the particle. Initially the particle was here. Right. This is my wave, right? The particle was here. When I rotate it, what is happening? Sorry. When I rotate it, what is happening? Particle is going down. Right. So this is how the motion of particle is. Actually, it is logged. Okay, it is some It is jammed somewhere. Okay, so I'm unable to show that properly because it's not moving smoothly. That's the issue. So what is going to happen to the particle? The particle is going to come down. Okay. Wave equation. In order to get a wave equation, we are going to take this equation. Okay. Y is equal to a sine of kx minus omega t. If I differentiate, did I take omega t minus kx? Okay, I will follow with that. Okay, omega t minus kx, and I am going to differentiate it. If I differentiate, what will I get? Omega a cos of omega t minus kx. If I differentiate this again, what will I get? D square y by dt square minus omega square a sine of omega t minus kx. And if I take the same equation and I am going to differentiate this equation with respect to x, this was differentiated with respect to time. Now we are going to differentiate the same equation with respect to x. As long as your syllabus is concerned, for example, NEET examination, okay, or any competitive exams, they are not going to ask you to derive. They want you to have the final solution alone. So remember the final answer. For board, you can just derive and see. If you have any doubt, please ask me. So if I differentiate, I will be getting minus Ka sine of omega t minus kx. If I differentiate it again, I will be getting minus k square a, sorry, this will be cos and this will be sine. I will correct it. Okay. If I divide them both, if I divide this equation with that equation, I will be getting sine term got cancelled. Okay. So omega by k is velocity. So omega square by k square will be velocity square. And what velocity, sir, it is? This is velocity of my wave. Okay. So I can rewrite that as d square y by dt square is equal to velocity square into d square y by dx square. D square y by dx square. Any difficulty? Any difficulty? No, sir. They have given a wave function. They are asking you to find the velocity. So take this question as homework. What you have to do? This is y, sir. You need to find, in this question, you need to find d square y by dt square. Find that. Also, find d square y by dx square. Substitute this value in this equation. Find this value, find that value, substitute the value in this equation, you will get the velocity. Sir, is there any easy method? Yes. What you can do? We know that velocity of wave can be written as omega by k. What is omega here, sir? 6. What is k? 4. If I am dividing, I will be getting 3 by 2, which is equal to 1.5. But try to solve using this method also. Okay, this is for your better understanding. Relationship between phase difference and time difference. What is the relationship between phase difference and time difference? Okay, just simply remember this formula. Phi is equal to omega times t and phi is equal to omega times, sorry, k times x. So if they are asking you to find a phase difference, then you need not do anything. Just go and see whether they have given x value or t value. If they are given time, then multiply omega into t, you will get the phase. If they have given x, multiply x into k, you will get the phase. This can also be rewritten as omega can be written as 2 pi divided by t and k can be written as 2 pi divided by lambda. Okay. So if they have given lambda and x, use this. T and t, use that. A transverse wave is traveling along x-axis. So which of the following is, okay, wave is traveling in x-axis. So wave is traveling, which is x-axis, this is x-axis. Wave is traveling in x-axis. Particle can travel perpendicular to this because it is a transverse wave, right? Transverse wave. So particle should be perpendicular. Particle can travel in y-axis or particle can travel in z-axis. Okay. So along x-axis, no sir. X-axis, no sir. Y or z is correct answer. Okay. If there is not this option, then you can go with this option. If they have given x and z, so x cannot be possible because particle is traveling in x. Wave is traveling in x, then particle should travel perpendicular to that. Okay. Which of the following equation represents a transverse wave traveling in y-axis? Wave is traveling in y-axis. Okay, usually the wave was traveling in x-axis. So the direction of wave is represented from what? This one. So it should have wave y term, sir. Sir, everyone is having y term. Okay. They have mentioned as transverse wave. So if wave is traveling in y-axis, then particle should oscillate perpendicular to it. So particle should oscillate in x or z-axis. Here, the particle are in y-axis. Particle is oscillating in y-axis. Wave is moving in y-axis. This is not transverse wave. This is longitudinal wave. So if it is along, they haven't mentioned positive or negative. If nothing is mentioned, we take that as positive. Okay. So if that is positive, then this is correct. If negative, this is correct. Okay. Any difficulty? No, sir. A wave is represented by this equation. They are asking you to find the frequency. From this equation, my omega is equal to 8 and omega can be written as 2 pi f. So what will be my frequency? Just calculate 4 divided by pi. Simple question, sir. Okay. Just from the wave equation, you can solve such a questions. A wave is represented by this notation, sir. Okay. They are asking me to find the direction. What will be the direction? Sir, this is positive, this is positive. Then wave is traveling in negative direction. So negative, positive, positive, positive cannot be true. Then what will be the velocity? Either you can use which formula? Differentiate the whole wave d square y by dt square is equal to v square times d square y by dx square and find the answer. Also what you can do? Velocity of wave can be very well written as omega by k. What is omega here? Sir, 15 pi. What is k? 10 pi. Divide them both, you will be getting 1.5. Okay. What you will be getting? 1.5. Okay. The traveling wave in a string is represented by, there is a wave traveling. Okay. What are they asking? The phase. So phase can be written as omega times t or else k times x. They have given me distance. They have given me x value. So which is better? So kx, because we don't know the time. So what is the value of k from the equation? K is pi by 4. Right. And what is the x value here? Sir, 4. If you are solving this, you will be getting pi radian. Any difficulty? If at all you have any difficulty, please do let me know. A steel wire. We have a wire which is made up of steel. Okay. So far we are using wave velocity, wave equation formula. Now they are giving steel wire, length is given, mass is given. Okay. And tension is given. Then they are asking you to find the speed. So speed of transverse wave, we know that speed of transverse wave can be found using the formula neta divided by rho or else tension by mu, which can be written as, so these are all not same formula. You can use this formula or this formula. M times L. So which formula, sir? This formula or that formula? Both are the formula of transverse wave only. Which formula are we going to use? Based on the data, they have given tension, length and mass. So this formula is suitable. Tension 60, length 0.72 divided by mass 5 into 10 power minus 3. Right? Cancel it out. 12 root of 120 into 72. 120 into 72. See, if I am solving the sums too fast, because number of lectures allotted are less. Therefore, in order to teach you more question, I have to take the lecture bit fast. If you are feeling the lectures are fast, you can please let me know. Okay. I shall try to reduce my speed, or else I will give you some more question as homework. So my answer is 92.95 meter per second. Okay. Or else you can write this to be approximately 93 meter per second. So in summary, what did we see? What did we see today? How can we find the velocity, right? Velocity of transverse wave, velocity of longitudinal wave in different medium and different things. Okay, so this is the velocity of longitudinal wave, sorry, transverse wave. This is the velocity of longitudinal wave in different medium, extended solid, solid, liquid and gas. Then we learned about Laplace correction. It was gamma times P divided by rho. My P and rho are looking the same. Okay, then we saw velocity of wave can be written as omega divided by k, correct? Then velocity of particle maximum value is equal to, what was the maximum value? Omega times a. This is what we thought. Equation of wave, how to find whether this is the given equation is of wave or not? We can use this formula. dt square is equal to v square by d square y by dx square. Okay, so these are all the things that we saw today. Just go through them. If you have any doubt, you can let me know. Few sums I have given you as homework. You try to solve them. Okay, use the equation formula and get the answer. If you have any doubt, please let me know. Okay, so with this, I would like to wrap up the lecture. Any problem, you can tell me. Thank you so much. Have a nice day.